Unit 4, Part 2, Access Control Models. Access control models. They consist of discretionary access control, mandatory access control, and role-based access control as described in the book. Role-based access control may be defined as core RBAC, role-based access control, which is basically you define a bunch of roles and the membership of a user in a role determines what access they have, versus hierarchical, where you attempt to model the hierarchy of the organization or the hierarchy of roles within the access control model itself. Discretionary access control, where the creator of an object is its owner. Objects are created, the owner of the object has full authority over that object. The owner determines the access right. You created it, you can decide who is allowed access, who is denied access, you can even lock your own self out if you want. Access control is at the discretion of the owner. If you create an object, it's entirely up to you what the access controls are. If you create a file, if you create a directory, if you create a program, you get to determine what the access rights are, who else is allowed to access it, and who may be denied access. It's usually implemented through access control lists. An access control list is a kind of data structure associated with an object that lists the different types of user and what rights are associated with that type of user. Typically, the owner of the object is a type of user, and the owner has all rights to the object as the owner. Other folks may have limited access rights or stronger access rights, and usually in an access control list there's a category of and everyone else, or in Unix it's called the world, which is if you are not otherwise specified, here's what the default rights are. It provides for flexibility and reduces central administrative needs. If the people who create objects have the authority and the responsibility to create the access lists, then you've eliminated a lot of work that a central access management authority would have to undertake otherwise. It's up to the object owners. You've decentralized it. You've reduced the central workload. You've reduced the possibility of a bottleneck in terms of determining and allocating access control rights. But it also gives users the rights to set dangerous permissions and to inadvertently allow malware access to an important resource. If a user downloads even inadvertently and installs malware, that malware immediately runs with the access rights of the users themselves. And the user can also be fooled into granting that malware additional rights if the user has the ability to do so. Now, mandatory access control is a whole different thing. The owners don't have the discretion to set access rights, or they have strictly circumscribed discretion to set rights. They're basically set by the organizational policy. So somebody in an organization has to determine who has access rights to what type of object, set that policy up, and ensure that everything that's created in the organization follows that policy. Even objects created by a user inherit these policy-based rights that can't be changed by the owner. I create an object, but it inherits kind of the template or boilerplate of the access rights determined by the organization, and I only have a very limited ability to change these inherited rights. It traditionally is involved in clearance and classification policies, what we've seen in the so-called military or national security information access control policy, where you've got clearances of secret, top secret, and so forth, and classification of data following into similar categories. It can apply to other policies as well. You can have mandatory access control that doesn't involve this kind of hierarchical clearance and classification policy. Now, mandatory access control based on clearance and classification policies, in that particular case, subjects and objects have labels. In other types of policies, they have labels too, by the way. But this is specifically required for a clearance and classification policy. Objects have classification assigned to them. An object without a classification, one, shouldn't exist, and secondly, may end up with a default classification assigned. Decisions on whether to allow or deny access are made by comparing the label assigned to the subject, what is the subject's clearance, with the object's label, what is the object's classification, and in applying the overall mandatory access control policy. This is a simplified model of how mandatory access control applies to a clearance and classification type security scheme. Again, you can have mandatory access control that applies to other schemes, but in general, it's used for this type of purpose. And here is our refresher diagram on what these classification clearance levels are. Is as you go up the level of clearance, you end up at higher levels of trustworthiness. You have individuals, processes, organizations, facilities that can house more highly classified data. If you are allowed to access an upper level of data, you can also access data at a lower level. The classification is also hierarchical. The subjects, meaning the humans, but also computer processes, programs, and facilities housing things, have a clearance assigned to them as a label, and the data itself has a classification assigned as a label. And the process of determining access or access control involves comparing the labels and making sure that the subject's label is at least as high as the object's label, if not greater. Access control models. You also have role-based access control, which is access policies expressed in terms of the organizational roles of the user. You know, are you an administrative user? Are you a developer, an IT developer? Are you an IT administrator? Are you an executive? Are you an auditor? These are all roles. Assigned to each role is a certain set of access rights. If you perform the duties or assign that role, you inherit those access rights from your role. The roles contain the bundle of access rights needed to perform a function, and the users are assigned roles inherit the access rights of the roles. And again, we have core role-based access control, which is you just define the roles. The user is a member of a role, end of story, versus hierarchical, where you have a whole structure of roles, and lower-level roles instantiate or qualify the higher-level roles. Core role-based access control has a many-to-many user to rights mapping, is supported by the role. So a particular role has many access rights and many users can be associated with the role. You can also have traditional group-based access control. In traditional access control lists, you can assign rights to individual users, but you can also assign groups. And those groups are, in a way, kind of very primitive, simplified roles. So core RBAC is also, in a sense, supersedes or includes traditional group-based access control as a subsidiary category. Now, in hierarchical role-based access control, you can set up a role structure that mirrors the organization structure, perhaps mirroring the organization chart, or mirrors some sort of abstract policy of, generic role A has access to B, C, and D, but a subcategory of that generic role has more specific access rights to certain other things. You may have a general role that is, member of legal, and you may have within member of legal separate specific access roles for attorneys versus legal assistants versus administrative folks in the legal department. It can also support separation of duties. Hierarchical role-based access control can support splitting tasks among different individuals by the way that the roles are defined in a hierarchy. Now, there are different technologies and techniques for access control as defined by the book. You've got on the first hand rule-based access control, which is if X then Y. If something is true, then grant access, then deny access. This is a more generalized case of the access control list that we've looked at previously. You've got constrained user interfaces. Don't allow the user to access via the user interface. You don't allow them to get to that web page, that URL. Don't allow them to execute that command. Don't allow them to look at that table in a database. Basically, constrained user interfaces fall in the categories of a constrained or restricted command line shell, where there are certain commands that you just are not allowed to use. A database view as a way of accessing data as opposed to granting access to the raw tables. You create views that restrict the access of users. And then you've got user interfaces, which are ways of constraining via, say, a web interface. You can't use certain web pages or can't view certain web pages that you're not allowed access to. Problem with constrained user interfaces is that a sufficiently crafty user may figure out a way to either break through them or to combine data from different allowed interfaces to generate something that they actually shouldn't have access to. Now, the access control matrix is more a way to represent access rights than it is an actual mechanism. But as a way to represent rights, it includes two mechanisms. A capability, which is Think of it as a key ring that is owned by the user. It is a set of access rights that belong to the user themselves, and that, subject to certain rules, the capability can be loaned or cloned and duplicated and granted to other folks. And then you have the access control list, which instead of being associated with the user, is associated with an object. Content-dependent access control is where access to an object is determined by the content of the object. A good example of this in contemporary use is something called data leak prevention. Data leak prevention is an attempt to use software that examines data exiting an organization to see if it contains sensitive information, specifically stuff like bank account numbers, social security numbers, credit card numbers, stuff that you can find by looking at patterns, where you've got a specific format for the sensitive data. It examines the data going out in email and file uploads and so forth, and if it sees something that looks like it's potentially sensitive data, it will alert you and alert the security administrator to do something about it. So this is an example of content-dependent access control, where access is determined by the content. It's not so much you can read or write file X, it's more if file X contains credit card numbers, then it's subject to this access restriction. And then you've got context-dependent access control. Look at the context in which the data or user action would occur and make an access decision based on that. Your access is in part based on what you've done previously. You look at the entire range of tasks or steps that have been performed previously, and you assess your rights to execute this command based on what you've done prior to that command. There may be prerequisites where you have to do A and B before you're allowed to execute C. Conversely, there may be cases where executing C after A and B sets off a warning flag because it indicates there's something not right. If there's an incorrect sequence, then something bad may be happening, and that should be denied in terms of your access control technique. And that's it for this lesson on access control.